Assalamualaikum guys and good afternoon. This chapter is about design basics, understanding the functional ingredients. As you know, many of functional ingredients are prone to degradation and they can interact with other components in the food matrix, leading to loss in quality of the functional foods. So to overcome the problems, what we will cover in this chapter, we will cover a lot about interaction of bioactive ingredients with the environment and ways to reduce this degradation. The learning outcome, number one, is functional ingredients carry bioactive compounds, and LO number two, to protect bioactive compounds, functional ingredients are micro-encapsulated. What are the material used and what are the processes involved? Now we're going to look at some examples of how bioactive compounds interact with their environment. The learning outcome for this part is that each bioactive compound is unique with specific stability issue, and this could affect efficacy, safety, and sensory properties of the food. In its natural environment, we know that bioactive compounds are well protected and therefore they are stable. However, after the process of extraction, these compounds are getting exposed to environmental factors like oxygen, like oxidants, sunlight, etc., and causing them to lose its efficacy or safety or sensory properties. So they are no longer stable, no longer appealing, no longer suitable to be used as ingredient in functional food. The first example I'd like to use is iron. Direct addition of iron into food may reduce its bioavailability through interaction with compounds such as tannins, phytates, and polyphenols. Free iron is also known to catalyze the oxidation of fats, vitamins, and amino acids. These interactions can affect the sensory characteristics of the final food formulation, as well as decrease the nutritional value of the food due to iron-induced catalysis of deteriorative reactions. The interaction of calcium with proteins can cause unwanted coagulations or precipitation of the protein, especially in calcium-fortified protein beverages. Calcium is naturally present in dairy products, but there is interest in fortifying other protein products with calcium, such as soy protein beverages. Calcium fortification of protein-based beverages may be achieved with addition of calcium chelating agents. However, this may result in undesirable taste when high levels of calcium fortification are desired. Omega-3 fatty acids are highly susceptible to oxidations and have an inherent fishy taste and odor. Probiotics are live microorganisms that must remain alive during processing, storage, and gastric transit to fulfill their desired function in the body. As probiotics are sensitive to heat and moisture, keeping them alive during food processing and storage is not easy. Even in fermented dairy product applications, the survival of probiotics during storage still remains a challenge for the industry. Another example is a phytochemical known as Resveratrol. This is a naturally occurring non-flavonoid polyphenolic compound present in plants such as grapes, berries, and peanuts, as well as in cocoa and chocolate. Resveratrol is photosensitive and it can benefit from microencapsulation to maintain its stability when added to food products. Another example is proteins. Proteins have traditionally been encapsulated for pharmaceutical applications, and protein-derived peptides and amino acids are also being isolated from their source to enable addition at the correct dosage required for physiological health functions. The direct additions of these components into food and beverage formulations can result in an undesirable bitter taste and astringency. And the final example is fiber. The trend of adding dietary fibers to food and beverage formulations that traditionally do not contain these fibers is increasing due to the increasing evidence of health benefits of high fiber diets. Examples of dietary fibers for which in the United States the FDA has allowed health claims are beta-glucan from oats and psyllium fiber. High levels of fiber, however, need to be added in the final food formulations in order to make a health claim. The problem associated with the addition of high levels of dietary fibers to food and beverages are the unpalatability of the high fiber ingredients and the significant effects they have on the viscosity of the final product. So those are just examples of possible interaction between functional ingredients with its environment. So how do industries solve the problems? One way is by using microencapsulations. This is a process by which a core, that is the bioactive or functional ingredients, is packaged within a secondary material to form a microcapsule. The secondary material, known as the encapsulant matrix or shell, forms a protective coating or matrix around the core, isolating it from the surrounding until its release is triggered by changes in its environment. This avoids undesirable interactions of the bioactive with other food components or chemical reactions that can lead to degradation of the bioactive, with the possible undesirable consequences on taste and odor, as well as negative health effects. Microencapsulation parts of the lecture will be covered in class because it is too technical and there's a lot more to cover. So never mind, I'll see you in class and happy learning.